Okay, a class is an example of a code block within Python. And so the syntax for defining classes is somewhat similar to the syntax for a while loop or a function. We have a keyword class. Then we have what the class name we're going to use. Within parentheses, we specify a class to inherit from, and Python classes always need to inherit from something. So there's a basic class called object that we can inherit from. Then a colon indicating that a code block is about to begin. And then an indented set of code blocks, and the class definition ends when the indentation returns to the level that it was when we started our class. So let's do a basic example of this. So we're going to define a 2D point. And we're going to start off really basic, and we're just going to define a single method. And a method is a function attached to the class, and the method that we're going to create is called a constructor. And in Python, that method is always named this double underscore init double underscore. Now this constructor is the method that's called by Python whenever a new instance of the class is created. Okay, so another thing so here's our class down here. I named the class point, and then it inherits from object. And so here's my constructor, the init function, and you can see we have 3 arguments here. Now the first argument is that we always have to provide a variable as the first positional argument that refers to the specific instance of this class that we are modifying in the constructor. And by convention in Python, this variable is called self. Now this is only a convention. We could use a different variable name, for example this, which I think is what is by convention is used in C++. But we always have to provide this variable, which we're calling self. I then have these 2 keyword arguments, x and 0, and just like every other function, I can have, remember, this method is just a function. So I have positional and keyword arguments. And so here I'm providing, this will be our default x value is 0, and our default y value is 0. And then I create an attribute of this point attached to our self instance called x, and I'm assigning to it the value that's passed in to the method variable x. And I'm also going to create an attribute of this point called y, and I'm going to assign to it the value that I pass in to the method with the variable y. Okay, so that's my definition. And then how do I use it? Well, I can construct a point. And here's the syntax for calling the constructor. I give it the class name, and then parentheses, and then my arguments. You see, I'm only providing 2 arguments, because the self argument is always provided implicitly by Python. We do not, when we call the function, we do not provide self. That is provided by Python itself. So I create this variable p. It's an instance of point, and I can print these attributes that I've created, px and py. I'm just going to split the cell here. If I ask what type it is, p is of type point. That's our class that's defined in this main program that we're operating within the notebook. Okay, I can change x. So up here, I provided an integer value. I can provide a string value to it. And now when I print it, my x value is the string 5, where my y is still the integer 4. Now that's not a kind of behavior that we would typically want. We typically think of an attribute having a certain type of characteristic, and we wouldn't want a user just willy-nilly changing whatever is stored in that attribute. So how can we protect against unwanted changes to our attributes by the users? And this is where the idea of encapsulation comes in. So one approach to this is we can make attributes and methods private by providing a leading double underscore. So that's 2 underscores. And this, in a way, makes it private. In a language like C++ or Java, they're truly private. Those attributes cannot be accessed outside of the class itself. In Python, nothing is actually private. What Python does is it's going to kind of mangle the name of our variable, any variable that has a leading double underscore. But if I know the rules that Python uses to do this name mangling to obscure the variable, I can still access it. And actually what it does is it takes a single underscore, class name, and then our attribute name. But that's, so the first step to kind of making unwanted changes to our attributes is to make them kind of pseudo-private. And once we've made them pseudo-private, well, then we need to let ways for the users to access them. And this is done through what are referred to as getters and setters. And so instead of letting the user directly access an attribute to change it, like we did here, p.x, we make them private, and then we make the user interact with those attributes by calling a function. Now, what's the advantage of this, making the user interact with the attribute by working through a function? Well, we can do things like enforce data types. So here we have a getX and setX. So the getX just returns the value that we have stored in our private attribute double underscore x. And setX is a method that we call that we pass in a value that we want to assign to the x attribute of our object. And we can do things like check, is this the right kind of, so is this a real number? You know, if we're modeling a 2D point, a point in the plane, we only want to do that with examples of real numbers, which would be floats or ints. And if it is, then we can set the attribute, and if it's not a type that we want to be assigned to that attribute, then we can raise a type error. We can also put in range checking. So if it's a temperature, say a temperature Kelvin, we could enforce that the number that's provided by the user has to be greater than 0, because there's no negative temperatures in the absolute Kelvin scale. So this lets us enforce that the data is of the type we would like it to be. So here I've just defined a new class called point1, and when I call my constructor, I call this internal method setX and setY, and this does the type checking for us so that I only let the user assign to the attribute real numbers. So here I create an instance of point1 that I call p1. When I create it, I assign a 5 for the x value and 3 for the y value. And we can now get at these attributes through the get methods that we've defined. I'm just going to split this cell here. And so you see I could get at 5 and 3. If I try to print p1x directly, I'll get an attribute error that point1 has no attribute double underscore x. And that's because of the name mangling that's been done by Python behind our backs. But we can always get at that attribute through our get method. Now when I go to try to modify the attribute x, I have to use my setX method. And so then when I try to pass in the string 5, I get the type error because my class had said x must be a real number. Okay, so this has been the method that I've primarily used encapsulation with these getters and setters. But Python has another approach that would probably be considered more Pythonic, a more less cumbersome way for the user to interact with your class, and that's through what are known as properties. And so I illustrate this with this third class definition, point 2. So here, again, my class consists of two attributes, x and y. But the way that I create those is I write these functions, which are essentially getters and setters, like we did in point 1, but we have decorated the function with this at property. So this is a decorator, and we're not going to go into the details of decorators in this class, but basically a decorator is something that takes a function as an argument and returns a new function. And so once we declare this at property, we define a method. In this case, we're going to call it x. And the result of this is that the function, the class, will have an attribute self.x. But it's not an attribute in the same sense that we had up here in our initial class where we just have self.x. It's really kind of a shorthand for us interacting with these methods. So we now have, when we call this line up here, okay, well, I got ahead of myself here. So this is like our getter. This is how we return the attribute that's part of our class. And then once we've defined a property, x, we create another function and we decorate it with this x.setter decorator. And so then this creates this function here again called x. And this is called whenever we are trying to assign a value to x. So right here, when we do this self.x equals x, what's really happening is this x-setter function is getting called, where we check to see is this value that's getting passed in that we want to assign. So this x here is then our argument in our setter. We do our type checking to see if it's a real number. If it is, then we go ahead and I'm going to set it to this private attribute double_x. But to the user interface, they can just interact with this point directly with the self.x. So it just looks like it's a regular attribute, but it's being accessed through this setter function that allows us to do type checking, range checking, etc. So I do that with both x and do it with y. And now when we create this point, we have this point 2, which we've called, we pass in an x value of 5, a y value of 4. We can print those out. Yeah, that's what we have. But if I try to do something like p2.x equals 5, I get my type error because I'm not doing direct assignment to x. This is just hiding. It's a nice syntax that's hiding from me the fact that I'm actually calling this function, and this function is doing type checking, and then if my types are satisfactory, then I'm assigning to this hidden variable, this private attribute double_x. And of course, that's when I call my constructor. That's being done here. And when I go to construct it, it's like, the string 5 is not an appropriate type. I'm not going to let you build something. And let me see, I got my notebook a little out of position here for my recording. I can, if I do, like I try to access the R attribute of P2, there isn't one, but I can certainly assign one. So the issue here is that once I've created a class, nothing stops me from adding attributes to an instance of that class. But so now if I print, let me add a cell here, if I print p2.r, or evaluate it, I'll go ahead and do a print. It has the attribute 5. But if I come up here, where's my p2? I'm going to just create another variable, another instance of my point2 class. and I'll call it P3. And if I print what P3's R value is, it doesn't have one. And that's because when I do this assignment, it creates an attribute for that instance of the class, but that attribute is not shared with the rest of the instances of the class that I might create. It's only it's local to that particular instance of a point2. And then, again, I can't assign to an attribute. Okay, so that helps us to ensure that we can have control over how the user is interacting with our class. Okay, another way that we can use a class to ensure data consistency is we can decide what the underlying representation we want to choose is, but we can provide different manifestations of that to the user. So we're going to illustrate that with another class, again representing a 2D point in the plane that I'm going to call point3. And if you remember from your geometry, I can think of a point in the plane either in this Cartesian coordinate systems, x and y, or in a polar coordinate system where I think in terms of r and theta. But what we wouldn't want to do is we wouldn't want to let the user set both an x and a y value and independently set the radius and the angle, because they could set them in a way that's data inconsistent. And so what we do here is we're going to define a 3D point where we're storing our data in a Cartesian coordinate system x and y, and we keep our data consistency checks so that we make sure that they work with real numbers. But I will return, I'll create a property r that is the radius of the point, and a property theta, which is the angle of the point. So let's go through this. So we can make a new point, call this P4. I don't know what state we're actually at. And I can do 5 and 4. But then I can print what the radius is with P4 and what the angle is for P4. And this is in radians, so if I wanted to convert this to degrees, I could do that. Ooh, typo. So I have a radius of 6.4 and an angle of 39 degrees for my point x equals 5 and y equals 4. Now what I can't do is I can't independently set r. So I can't set p4.r equal to some value 8. I get an attribute error. I can't set attribute. So I can let the user report and interact with the class with these other attributes, but it's always stored in a single format, in this case the Cartesian, so they ensure data consistency in my data representation.